This is actually the note sheet that goes along with the peach colored sheet that we did yesterday. So have that handy, folks. Exposure up. Yeah. Okay. I'm going to go through this sheet really, really fast, but I'm going to also show you how to work these on your graphing calculator if you don't already know how to graph these, because that will be something really handy to know how to do when you take the ACT and such, if you know how to graph functions like that. So we'll start with, they have them categorized: vertical shift, horizontal shift, reflections, and then stretches and compressions. Okay, so you can kind of look through these on your peach colored sheet and just follow along. So example 1, you are shifting these two functions. You basically have two different shifts going on. They want you to graph them on the same coordinate plane, and then I'm going to go ahead and write what transformation each one is doing. But I tell my algebra kids, if you strip away all of the numbers, what is the parent function that's left over? What are you starting with for both of those? Absolute value. So it's like basically y equals absolute value of x, and I am going to graph him in black. He is the standard function. He's up 1 over 1, up 1 over 1. That's what he will look like, the absolute value. Okay. I'm going to do these in 2 different colors. First one in blue, second one in orange. Okay. So what does the plus 4 do? Up 4. And what's the minus 3 do? Down 3. Okay, so up 4, like this. That's what he will look like. Down 3, like this. That's what he will look like. Almost too easy, right? Your new orange. Okay, now, how do you do this on your graphing calculator? Do you guys know how?
No.
To graph functions? Okay. First things first, the last time we used your graphing calculator, we were plotting like some dots and stuff or whatever. You would go like stat edit and you type some bunch of stuff in your list. Okay. I'm going to have you put your stat plot off. So hit the second button and go to y equals. If your plot is on, go ahead and click enter and turn it off. Okay, because we don't want it to try to graph functions and dots at the same time. Okay, because it's just going to be kind of confusing. So if you're going to try to graph the dots under your stat edit stuff, you want to make sure those plots are on. Otherwise, we're going to turn them off. So y equals, I have a function already in here. I'm going to clear it out. And we want to graph, I'm going to first grab just the absolute value, okay? Where are the absolute value bars on your calculator? Do you know? Yeah, you hit the math button and it gives you everything. Math button is right here underneath of alpha. Okay, it gives you everything that you will need. So I have fractions, decimals, blah, blah, blah. There's a cubic right there. If you go over to number, it's the very, very first one, ABS. You hit the over key, ABS, enter. And I'm just going to do the absolute value of x, okay? And then the second one, I'm going to have it graph all of these for me. So math, absolute value of x, and then I'm going to do, what is it, plus 4? Plus 4. And then I'm going to do it again. Math, absolute value, x, minus 3. Enter. Graph. There's my first one. There's my second one. There's my third one. Oh, can you not see this very well? No? No? I got to do... Nope, it's turning it the other way. There, is that helping?
Yeah, a little bit. There you go. That's better.
Can you see it on my screen? Okay, I can see it on here, but I can't see it on that screen. What? What? Redo it all. How do you do what?
Get the full graph. That's only showing half.
Hit your window button. Window. Window. Okay, so you want to go, clear. Y equals, and you go there. Okay? Is that where you want me to start, Katie? How to insert the absolute value? Okay, so I'm going to go down to the fourth one. And you hit the math button. Math is right underneath of alpha. You see it? Math. And you hit the over key for number and hit enter under absolute value. It should just say ABS, and it will insert that absolute value bar there. Okay. And then I just graphed all of them. Absolute value of x, absolute value of x plus 4, and then the other one minus 3. And then if you graph them all, it will show you exactly the same thing as what I did. It'll make like little chevrons, which is kind of cool. Bradley Morris last year, he was like notorious for like coming up with weird things. He would then like even shade those. So like, yeah, it was just weird. He had the calculator that would change different colors, like yours does, different colors or whatever. So he'd do like chevrons. He'd also do chevrons that go the other direction, and then like different colors. It was cool. Okay. Questions about that? So graphing these, you can do this on your calculator for the ACT if they ask you any sort of situation where you think graphing would help. Okay. So there's that. All right. Now let's go to horizontal shifts. Okay. So this function right here, if I strip away everything, what's my original parent function? 1 over x, and what does he look like? The boomerang equations. I have a vertical asymptote here and a horizontal asymptote here, and I have like these little guys. Okay. Now shifting this thing is a little bit tougher than normal for most people. If I look at the x minus 3, what's that minus 3 doing? It's going to the right 3, okay? People say down 3 a lot, but down 3 would look like this. This is down 3, right? The minus 3 would be on the outside. So if you want to write that so that you can compare, that's okay. This would be right 3. Yeah. 1 over x minus 3 is to the right 3. So basically my horizontal asymptote stays the same, but if I'm going to the right 3, my vertical asymptote is going to change and be here, and my new function is going to look like this and look like this. Okay? So the vertical asymptote will change when you're moving him left and right. Okay? Same thing for the second one. What's he doing? Oop, I'll go in orange. What's he doing? Left 4. So I'm moving my vertical asymptote to the left, and he looks like this, and he looks like this. Okay, my horizontal asymptote stays in the middle. So my horizontal asymptote does not move if you move him left and right. Does that make sense? Okay. All right, good. I don't know what's in this reflection box. Graph the functions, the square root of x and negative square root of x. And then graph the functions square root of x and negative square root of x. Okay, let's see what that looks like. Y equals, I'm going to clear these out. Clear, clear, clear. Okay, you don't have to go to the math button to hit the square root function. You can just do, it's like second x squared. X, we're going to do the square root of, negative square root of x. Insert negative. Okay, and go down, and then we're going to do square root of negative x. Can you have the square root of negative x? Will it even graph that thing? Okay. You can have the square root of negative x, but the only numbers that you are allowed to plug in for x are negative numbers, because then that double negative will make that positive. Does that make sense? So if you think about the square root of negative x, that will be only for negative numbers. So the normal square root function, normal square root function looks like this, but if I'm only allowed to plug negative numbers in, it might go like this instead, down here. Okay? And these are reflections either across the x or across the y if I graph all of them. The first one, there's the original. Okay, now it's graphing the reflection across the x-axis and then the reflection across the y-axis. So this one is a reflection across the x-axis. This one is a reflection across the y-axis. Okay? And the negative's out in front. I think you have that all written down on your peach-colored sheet, but if you need it there again, that's that, okay? When you're reflecting across the x-axis, the negative goes out in front of the entire thing, but the negative goes inside parentheses when you're reflecting across the y-axis. Okay, next page. All right, x or y-axis. Ugh, I don't like this. Do you guys know what the graph, what this original parent function is? Do you know what this thing is? What is that thing? It's not just y equals x. That's the step function. Okay, we didn't talk about him. We won't talk about him very often. I won't put him on a test. You might see him on a homework assignment at some point, but that's the one where you're always rounding down. So you're rounding down, you're rounding down, you're rounding down, and he just goes up like your age. I can't see where these lines are, so I have no idea if I'm doing this right. Well, I'm doing it right, but I don't know if my lines are in the right spot because I can't see. Oh yeah, he looks something like that. Something like that. You only have to put a couple of them. You don't have to put all of them if you don't want to. Okay, so this guy, this first one, this negative, he reflects him across the X or Y? Which one? X. And the negative's out in front, he reflects him across the X. So I'm going to take this guy right here, and I'm going to move him down. So he's going to look like that. This guy right here is going to move him down like this, and like this, and like this. And this guy's going to stay at the same spot, but then I'm going to have these. You see that, how that's reflected across the x-axis? Yucky. Now, notice that the left and right-hand side, the left side is still a closed dot, the right side is still an open dot when you reflect across the x-axis. But that is all going to change when we do the y-axis. Reflect over x. Second one is a reflect over y then. All right, so if I take these guys and I move him over, he is now here and he's an open dot. He is now here and he's an open dot this way. Here, open dot this way. This one is going to do this. This one is going to do this. And here, and here, and here. Something like that. So he'll be kind of like butted up against the blue one, but his will be like flipped. If I take this guy and I flip him over here, he'll be butted up against that blue one. But the open dots and closed dots will switch. Okay, that one's a hard one. I usually don't look at stretches and compressions a lot with greatest integer functions, but you can see how that negative is inside the parentheses versus outside the parentheses. Okay, stretches and compressions. Exhibit 4. Is that exposure up too high or good? It's too high? Okay. Is that better? Okay, example 4. We are starting with what? X cubed. X cubed is here at the origin and it goes up like this and it goes down like this. Okay? And the first function right here, what is that 2 doing? Yep. Vertical stretch by 2. Okay? So if you think about where these points are located on here, I'm just going to plot some points here. If I plug 1 into the cubic function, this is the point 1, comma 1, right? And 2, what if I plug 2 into the function? It should be at 2, comma something into the original. If I plug 2 into the x cubed, 8. This will be the 2, comma 8, okay? Now, if I vertically stretch him by 2, I'm taking the y coordinate, which is the vertical coordinate, and I'm stretching that by 2. So instead of it being at 1, 1, it will be at 1, 2. Instead of it being at 2, 8, it will be at 2, comma 16. He'll be up here at 2, comma 16. Does that make sense? And he'll go like this. He'll be really, really skinny. Really, really skinny. Okay? Does that make sense? Yeah? Okay. Now what's the other one doing? It's vertical also. Vertical compression by 1/4. Okay, so if my original point was at 1, 1, what's my new point going to be at? One comma 1/4. 1 comma 1/4. Okay. My second point was at 2 comma 8. Now it's at 2 comma 4. 2 comma 4. So he's going to go like this. He's going to be a little wider, like this. Okay. What's the trend here, like with numbers as far as width and skinniness? Two is skinnier, 1/4 is fatter.
Smaller numbers
The smaller the number, the fatter it is, right? The larger the number, the skinnier it is, the vertical stretch. Okay? Because if you think of people being really, really, really tall, they're really, really, really skinny, right? Well, usually, right? If you take me and stretch me out, I'm going to be like super skinny, but because I'm short, I'm fat. That's the way it goes. So, there you go. The bigger the numbers, the skinnier it is. All right. Now we have stretching a function vertically and horizontally. So looking at the differences between those. Let's just change these. I don't want to do any more greatest integer functions. Let's just say that this is g of x is 2x and h of x is, well, that's not very good either. But we'll do the absolute value. Let's do that. We'll change it to absolute value. We'll do it absolute value. That'll make things nicer, maybe. Maybe. Okay? So, if we start with the absolute value of x, y equals absolute value of x. Here, here. I'm changing those. Change to those. Okay? What's the first one doing? What's this guy? The 2 is not inside the parentheses or not inside the absolute values. What? Yeah, I think so. Vertical stretch by 2. Okay? Now, this guy is going up 1 over 1, up 1 over 1, up 1 over 1. Right? So it's like at 1, 1, at 2, 2, at 3, 3, at 4, 4. So what's my first dot going to be at here instead? 1, 2, it's going to be up 2 over 1, up 2 over 1, up 2 over 1, instead of up 1 over 1. So he's going to look like this. Ooh. Like that. Okay? Now, how is that different from the 2 on the inside here? What does this 2 do? Yeah, horizontal compression by how? By 1/2. When you're doing horizontal compressions, there's a little star on the outside of your little peach colored sheet that says use the reciprocal. Do you remember that? Okay, so horizontal compression by 1/2. What's a horizontal compression by 1/2 going to look like? If I make this, it's going to look exactly like a vertical stretch by 2. If I take the original one and I compress him and I make him half as wide, he's going to be exactly like the one that I have right now. So a lot of times, when I have vertical stretches, they look like horizontal compressions by the reciprocal factor. Does that make sense? Now, when does it not? When I start with functions like 2x plus 3, like that column that we did, if I would stretch that vertically by a factor of 2, it's not going to be the same thing as stretching it horizontally by a factor of 1/2. Or compressing it horizontally by a factor of 1/2, because that guy is like shifted and moved around and stuff. So he's not going to look exactly the same. Okay? All right, so sometimes they look exactly the same. I tell my Algebra 2 kids who are seeing for this for the first time, if I vertically compress a peanut butter and jelly sandwich, what's going to happen to it? It's going to horizontally expand, right? So sometimes they look exactly the same. All right, now combining transformations. We have how many different transformations do you think going on there? 4. There are 4 of them. A lot of people see 3 numbers and they say 3, but what are they missing? The negative in the front, okay? If we strip everything away, we're starting with the absolute value of x, right? Which looks like this guy. Okay? Now, if I don't know the rules, if I don't know these rules and the only thing I have to go off of is graphing that thing, I have to plot points, I have to plug stuff in. That's very tedious, not very much fun, right? But since I know the rules, I can just say, hey, this is what's happening to it. We said that there was 4 different things that were happening, and then I just plot him and we're done, okay? So, you go in order. Did I say go in order? Have I talked about order yet? Okay, sometimes the order matters, okay? If you're combining transformations, sometimes the order matters because if I reflect something and then I move it up, it's different than moving up and then reflecting, right? In some cases. So what order do you go in? Here is the rule. The x is right here. If I were to be plugging a number in for x, what would I do to it first? I would multiply it by 2, right? That is the first thing that's going to happen. So multiplying by 2, when it's on the inside of parentheses, is going to look like what? Horizontal compression by 1/2. That was the one we just did, right here. That's what he does. Okay?
If it's a stretch or compression.
Stretch or compression, if it's a number that's bigger than 1, it's a stretch. If it's a number that's smaller than 1, it's a compression. So if you think about, like, if I say somebody is twice as tall or 3 times as tall or 4 times as tall, those are numbers bigger than 1 that they are going to be bigger, right? If somebody is half as tall as somebody else, that's smaller, right?
But 2 is bigger than 1.
But if it's inside parentheses, you use the reciprocal, right? That's the rule. That's the one. That's the one thing. You look at the number after you use the reciprocal. So if it's inside parentheses, you flip it and then you say, okay, since I flipped it, it's a number less than 1. It's a compression. Yes, I see where you're confused. Yeah. So flip it first and then you can decide that it's a compression. Okay, good question. All right, and then after I multiply by 2, then what? -1, which means I'm opposite you. Right 1. To the right 1 unit. Okay, and I'm lazy, so I just put arrow 1. Okay, and then what would you do? After you take the absolute value, of course. The negative is going to reflect him over the x, and then the 4 is going to move him up 4. Okay, I'm going to do this with a pencil so I can, like, start to do some of this stuff. Horizontal compression by 1/2. That's going to make him skinny. Like here-ish. It's going to kind of make him skinny, okay? And then I'm going to move him to the right 1, so he's going to be here. My pencil is not working. To the right 1. My pencil is not working. I need a new pencil. To the right 1. So he looks like this now instead. Okay, to the right 1. Over the x-axis. Now he's down here, and he's skinnier. And then up 4. He's going to be here and skinnier. So my ending spot, or my ending guy, is going to look something similar to that blue one. Okay? After you do all of that stuff, he's going to look something similar to that. He's going to be half as skinny as what he was before. Right 1, up 4, reflected is down. Okay? Does that make sense? Yeah, all that stuff. All right? We're going to skip example 7 because it's a greatest integer function and I don't like those. So, okay, that's it.
Question.
Yes.
Is that in the worksheet?